exponential functions and logarithmic functions. Our objective for this video, we want to write exponential functions in logarithmic form as a logarithmic function, and vice versa. Write logarithmic functions as exponential functions. So we know a couple things coming in that are going to help us. We know what an exponential function is. Any function of the form f of x equals b to the x, where b, the base, is positive but not equal to 1, and x, the exponent, is any real number. We also know what an inverse function is. It's a function that undoes a given function. Okay, so let's take a look, and well, obviously we haven't defined logarithmic function yet, so let's define that. A logarithmic function is any function of the form log base b of x, where the b, the base, is positive but not equal to 1, and x, which is called the argument, is also positive, greater than 0. So this is b, the base. It's positive but not equal to 1. And this is the argument x, and it's also positive in the logarithmic function. The log function is designed to output an exponent. It's the name for a certain exponent, okay? Essentially, it answers the question, how many of one number do we need to multiply to get another number? Okay, it's providing us with an exponent. So let's take a look at some examples of that. So here's an example. 2 to the x is equal to 16. All right, this is an exponential function. The base of 2, variable in the exponent of x. 2 to what power is equal to 16? Well, if you're quick, you know the answer is 4, if you know your exponents. But what this is saying, if we're asked to solve this, it would be how many 2's do we need, whoops, the word need starts with an N, not a K. How many 2's do we need to multiply to get the answer of 16, okay? This is what if you were asked to solve this, hey, 2 to the x is 16, what's x? Well, how many 2's do I need to multiply to get 16? And again, if you know your exponents, you know the answer is 4. 2 times 2 times 2 times 2, 4 2's, you will get the answer of 16. Well, the log answers the question, okay? The log will give us the answer. If you don't know this, we get the answer using the log, and it looks like this. The log of base 2, the base, and the base, of 16 equals 4. Okay, so if we put this in our calculator, and I'll do that, begin to show you how the log works in your calculator. Now I'll go on here, and I'll clear. You have a variety of buttons I want to point out, and we'll kind of talk about a few of them here and there. Here's a log button down here. This is log base 10, when you just see a log button. This is the natural log button, which is the log base E. So the two most popular bases are 10 and E. However, this is the log base 2. Well, my calculator has the ability, and a number of them do these days. I can go into math, and under the math menu, I can scroll down or scroll up. It's easier to get to by scrolling up. And right here, whoops, letter A on my calculator, I have a log base, which is the variable base. I'll select that. And this allows me to put in any base I want. Well, I wanted the base of 2. In my argument, I put in 16, and the answer comes out to be, when I press enter, the answer is 4. 2 to the 4th power is 16. Okay, so using the logarithm, L-O-G-A-R-I-T-H, the logarithm tells us the answer is 4. Tells us the exponent, which of course is the number of 2's needed. Okay, it tells us the number of those 2's we need. We need 4 2's. 2 to the 4th is 16. Okay, so logarithm helps us when we're trying to solve these exponential equations or these exponential functions. And here's how these two are related. Here is using y instead of f of x. Here's an exponential function. Okay, this is the base. Remember, b is the base, x is the exponent, and down here in the log function, b is the base, and x is the exponent. Okay, so base goes to base. Okay, we saw that right up here. When we solve this up here, base in the exponential is the same thing as the base in the logarithmic. Exponent is here. The log outputs an exponent, and the exponent in the exponential, of course, is the raised number or raised expression up here, and then the y in the exponent is the argument in the logarithm, okay, the logarithmic function. So we've learned about inverses. The logarithmic function and the exponential function are inverse function. One can be used to undo the other. And this is key. We did a whole section on inverse functions, and that we can use inverse functions to undo one another. And so we can use the log to solve questions that have variables in the exponent. Okay, give me a second to get my act together. I'll go to let's do some examples because I think it'll help to see this. Go back and forth with this a little bit. And my paper is not straight. Is that straight? I think that's straight. Okay, let's express, we're going to start off by just simply rewriting what we have in the other form. So express the equation 5 squared equals 25 in the log form. Well, we know b to the x equals y can be rewritten in the form log base b of y equals the exponent x. So 5 squared equals 25 can be rewritten as log base 5, this is the base raised to the exponent, of 25 equals the exponent, equals 2. If we put this into our calculator, we're going to get 2 out. So these two equations are equivalent, the exponential form, the logarithmic form. Okay, let's do this next one here, example 2. 3 to the negative 2 is equal to 1/9. Okay, well, we know the exponential form, b to the x equals y, can be rewritten in the log form, log base b of y is equal to an exponent. So I have 3 to the negative 2 is equal to 1/9. I can rewrite that as log base 3, the bases are identical. The argument is 1/9, and the log is equal to the exponent, so it's equals to negative 2. Okay, let's go the other way. In example 3, I gave you the logarithmic form. Log base 7 of x is equal to 3, and I want to write it in the exponential form to get to know what x is equal to. So in this case, I have log base b of y is equal to x. I'm just going to rewrite this again. Is equivalent to the exponential form, base to base. The log gives me an exponent is equal to the argument. And so log base 7 of x is equal 3. can be rewritten in its exponential form as 7 base to the third, because the log is an exponent, equals x. And I can solve whatever 7 cubed is, I don't know, 240 something maybe? I don't know. And I can, x equals 7 cubed. Okay, these next two problems, let's actually do that math. Okay, the log base b of 25 is equal to 2, and I want to rewrite that in exponential form, and then I want to solve for b. Okay, well, I know log base b of y is equal to x is equivalent to writing in exponential form base to the x, base to exponent equals y. Okay, let's see here. One of the things I'll point out, I like to sometimes draw this kind of circle thing, b base to exponent equals argument. It helped me kind of with a loop. If I go up here, same thing up here, a little bit of a loop can help me. And so sometimes I'll think in my head, I'll think base raised to exponent equals argument with that little loop there. So let's rewrite it. This is log base b of 25 equals 2. I can rewrite that as b squared equals 25. And then I can solve for b by taking the square root of both sides. B is equal to positive or negative 5. But of course, our base is always positive, so b equals only positive 5 because b must be positive. That was one of our restrictions early on. So it can't be negative. Even though negative 5 works here, the base in the logarithm has to be a positive number. Okay, so b is greater than 0, so the only answer here is 5. Okay, last example. I gave you example 5 has an exponential, and we want to figure out what that variable is. What is the exponent that makes this true? Well, we know exponential function looks like this, and that's equivalent to the log function that looks like this. B base to exponent equals argument, base to exponent equals argument in this case. Okay, so we have this. So 5 to the x is 1 over 25. What is the variable that makes this true? Well, the log lets me solve this. I'll rewrite this. Log base 5 of the argument 1 over 25 equals the x. And again, I can write my little loopy here. 5 to the x is 125 to get me back to here. And so I'll put this into a calculator. Let's do that one together. I have a base of 5 down here. So let's I'll go back to my math, to my log base. I get to choose the base. The base I have is 5, so I'll write 5 in for the base. I'll go into the argument and I'll put in 1 divided by 25, and I press enter, and the exponent is negative 2. So here I have x is equal to negative 2. So I was able to solve this using the logarithm. 5 raised to the negative 2 power is 1 over 25. As a math teacher, I knew that, but many people might not know that, but the logarithm allows me to get at the exponent and solve for it and discover that it is indeed negative 2. So the key piece to all of these things is this equivalence right here. Base to exponent equals y, or equals argument, is equivalent to log base of argument equals an exponent, because the log allows you to output an exponent.